Yes, hello dear. Now, my dear friend, we are going to discuss important concept, important concept related to two-port network. Okay, but before that, it is my bit introduction. My name is Ravi Babu, and I have completed MTech from IISc Bangalore in 2010, and almost 10-year experience. Dear friend, I think very well. Unacademy platform is the best e-learning platform in India, and unfortunately that virus corona etc is going on, so you can utilize this time in study, and obviously if you are utilizing your time in well manner, then definitely you can score good marks, okay, in the coming exam, for example gate, ESC, any other PSU exam or state level exam, anything. Okay dear, now betaji, we are going to discuss our topic. Okay, so yeah, introduction of two-port network. Now, so dear, in two-port network, it is our first part, and it's my promise to all of you, definitely you will score 100% marks according to me from this topic if you will cover each part of two-port network. And my dear friend, on average every year, okay, on average every year, they ask either two-port directly question or the application of two-port in different topic. For example, power system, analog, okay, circuit theory, sometimes in measurement also. Okay, this is the thing. Now dear, I would like to ask you first question. What is the use of two-port network? Okay, what is the main purpose of two-port network? Why we require it? Can you tell me, anyone, please? Okay, so see dear, till now nobody, okay, is there. Okay, so bit introduction I am going to provide you about two-port. My dear friend, let us assume this is terminal A, okay, that is terminal B, and here C and D are. Now it is our two-port network, okay, two-port network. And my dear friend, this box of two-port network should be okay, it should be free from independent element. Independent, I'm writing in shortly, independent element. Okay, elements. Plus beta, our inductor and capacitor, should be initially uncharged. Okay, uncharged. That is the first property, okay, and which is very important related to two-port network. So dear friend, in two-port network, our this two-port system should be free from independent element, for example voltage source, current source, either AC or DC, and L and C also should be initially uncharged. Okay, till now it is clear to all. Now beta, See, I want to ask you two-port network theme. Why we require two-port? Okay, my dear friend, two-port is nothing but testing topology, testing method. So two-port means testing method. Testing method in which beta we apply either by V1 or 1 volt voltage source across the terminals A and B, and similarly V2 or any other voltage source across terminal C and D. In place of V1 and V2, you can also apply a current source I1 or a current source I2 here. My dear friend, testing method is nothing but simple method by which we can easily calculate output impedance or impedance seen from the terminal C and D, or the impedance seen from terminal A and B, or the beta transfer impedance from terminal first to terminal 2 or terminal 2 to terminal first. And also we can calculate current gain of the system or voltage gain. So two-port topology or two-port method has become multiple advantage. Due to these multiple advantage, it is very popular method, okay, in the electrical core as well as in electronics. Okay, dear. Now, beta, I assume that here current some I1, here voltage some V1, this voltage is V2, and this current is I2. Okay, dear. Now, beta, see, why we are assuming these current are entering into this system, okay, into this system. Now, question arises here. Can we use beta here independent supply? Obviously not. If we use here beta independent supply, these element will energize according to that supply, and system parameters, that means two-port parameters, may get vary, and due to this thing some error will introduce. To overcome this error, we never use beta here independent supply at the terminal CD and AB. Here we can say we have to use beta some testing method, voltmeter or ammeter, you can say easily. Okay, so here you can say one voltmeter, here you can say second voltmeter, and the reading of voltmeter V1 and V2 and the reading of ammeter, suppose A1 and A2 something, will provide you whatever we require. So this is the main task of two-port network. So beta, please mind it, here you can apply one voltmeter V1, okay, in such fashion, and here beta you can apply one voltmeter V2 in this fashion, and similarly current or ammeter somewhere here in this direction, and one more ammeter beta somewhere here A1. Okay, so it is A2 and that one A1. Now see dear beta, the two-port network, as I told you, is testing method, so we require voltmeter ammeter at port 1 or port 2. It is our port 1 and this is our port 2. Okay dear, port 2 beta. Now see my dear friend, port 1 my dear friend, I would like to suggest you that whenever you want to learn something about two-port network, you should keep one point in your mind. Related to port 1 and port 2, port 1 and port 2 are kind of beta those terminals across which we want to connect testing devices. Okay, now see dear, here beta terminal AB present, terminal CD present, so either you can apply some testing voltage here or voltmeter, or some testing voltage here or voltmeter. Okay, now see my dear friend, these voltmeter and ammeter we are assuming are ideal, so the drop across ammeters is 0 and the current through voltmeters is also 0. Okay, now see dear beta ji, what is the meaning of 2 port, okay, and 1 port? 2 port and 1 port. 2 port means a system which contains beta input terminal as well as output terminal, and 1 port means beta, for example resistance, it has 1 port, so you can provide some supply across this and excite that load. Similarly beta, inductor, capacitor, okay, diode, etc., all devices which have only 2 terminal, and here beta terminal or number of terminals are 4, so this is input port you can say, and it is output port. Okay beta, now see dear, till now I'm not getting any doubt, so I want to continue this topic, okay, without any delay. Now see dear, few students ask sometimes, sir, why we don't require any independent voltage source or current source here, as well as inductor and capacitor are initially uncharged. Why? See my dear friend, a 2-port network generally we consider linear. Obviously non-linear 2-port networks are also available, and please mind it beta, generally system are non-linear, okay, not linear. At least the transient period of the system will be non-linear. Why non-linear? Because the variation of temperature or due to the excitation system beta, there will be some change in current and voltage, and they are not fixed with respect to time. They will not be transient free with respect to time. So due to introduction of transient as well as variation of temperature, pressure, humidity, etc., the values of components may get changed. System may or may not be linear. But here dear, in 2-port network, our starting with linear 2-port network. Linear 2-port network. Now my dear friend, this network in our case is linear. Linear one, okay? Linear one. If you have any doubt, please ask, okay? So that we can discuss related to your doubt also. Otherwise, the discussion of this topic, according to me, will be meaningless, okay? Unacademy is providing beta kind of free knowledge to everyone. So you should appreciate that thing and should join every faculty, okay, related to your branch. Yeah. Now see dear, it is our linear 2-port network, and in linear 2-port network, nothing is present like independent sources and inductor, capacitor, initial charge. Now my question is beta, then let us assume beta we have one network in this fashion, okay, in such a fashion beta, okay, and we want to calculate, my dear friend, R naught across the terminals A and B. Here I write beta it is 10 volt. This is a 2 ohm. It is beta ji 80 volt. It is 8 ohm. Okay, or not 8 ohm. I'm writing it is 2 ohm. And this one is beta ji, let us assume 10 ohm. And it is 1 ohm. So tell me the value of R naught. Okay. Yes, everyone. Tell me the value of R naught. Okay, dear. Now, beta, to calculate the value of R naught, see, I am following two methods. Okay, in first method, beta, I want to apply here some testing method. Here some testing method. Okay, so see, dear, at the time of applying testing method, all the independent sources must be short circuited. You know very well why. Because beta, if these sources are activated, our calculation will disturb. Error will introduce because system is already in excitation mode. So my dear friend, just see beta, I want to apply here one voltmeter of 1 volt testing method. So 1 voltmeter beta here of 1 volt, and want to determine beta current through this voltmeter, and let this current is I. Let this current is I. Now beta, at the applying, I'm writing name of this signal also. It is voltage testing signal. It is voltage testing signal beta. So here I say, let us assume some current I. So I beta, and I, as I told you, when we apply testing method, our all voltage source and current source beta should be deactivated. Okay, should be deactivated. Okay. Now beta ji, we are going to deactivate our sources. So it is independent source, so short circuit. Okay, it is also beta independent source, so short circuit. This is also independent source, so short circuit. This is the thing. Now dear, it is our equivalent circuit. Whatever I have drawn here, all the independent sources will be short circuited. All the independent sources will be short circuited. Okay dear. Now beta, this I1 current, whatever we assume, not I1, actually I only. Okay, I current beta. This I current will reach up to that point, and then beta it will divide in two parts. Okay, so these are equal resistance. So we can write, my dear friend, it is I by 2, because equal resistance I by 2, and this is also I by 2. So now calculate the value of I beta. See, we are going to apply KVL in outer loop, my dear friend. In outer loop, what will be the equation beta? Minus 1 plus 1 into I, first draw, plus beta 2 into I by 2 is equal to 0. Okay, so drop is completed beta. Now beta ji, this I 2 and 2 cancels, so 2I is equal to 1. So here we can write 2I is equal to 1. Therefore I is equal to 0.5 ampere. Yes beta, so what will be this ratio according to this testing voltmeter? Here we can write beta, our R naught is nothing but this testing voltage divided by, okay, I'm writing here formula beta, testing voltage by current through testing voltage. Okay, current through testing voltage. Now see dear, beta, we can write testing voltage is 1 volt divided by current through testing voltmeter is 0.5, so it is nothing but 2 ohm. Okay, 2 ohm beta. See, at this moment all the independent sources are deactivated. Now beta, same question I want to handle like this. Okay, try to understand. Thevenin equivalent resistance, RTH, Thevenin equivalent resistance. So to calculate RTH beta, first open these terminals, and across these terminals we have to calculate our R. So see beta, all the independent supplies short circuited, to 2 and 2 are in parallel, and 1 parallel 1, so 1 plus 1 beta 2. So RTH, Thevenin resistance or Norton resistance, will also be 2 ohm. See dear, why we have discussed this example beta? We have discussed this example because for the better understanding of two-port network, the procedure whatever we use to calculate RTH or Norton resistance, Thevenin impedance or Norton impedance beta, almost the same method we have to use in two-port technology also. And you know, Thevenin impedance, Norton impedance, Thevenin resistance or Norton resistance, we can calculate by testing method. That's why beta, at the time of handling two-port network, okay, we should try to understand a few points. First beta is nothing but our two-port network should be free from any energy storing or any energy delivering element. Okay, this one. So till now it is the bit introduction of two-port network, which property we have to use or which property we are not supposed to use. Okay, now see dear. Yes beta. Now my dear friend, my question is to all of you, if we have one two-port network in this fashion, okay, in this fashion, V1, V2, then it is our two-port network beta, two-port network, and which is linear one. Okay, linear one. Now beta, my question is, what should be the direction of current? What should be the direction of current? So I am showing two direction beta. I1 should be this one and I2 should be this one. Or my dear friend, I1 by red color or this maroon color, or I2 in this one. Okay, tell me dear, which statement can we write regarding the direction of current? Okay, so beta, green one or maroon one? Tell me. The direction of current according to two-port circuit, which direction of current can be right? Okay, this beta, green one direction is right or maroon one is right? Okay, now see my dear friend, yes beta, now see, as I told you my dear friend, here this network does not have any active element. Okay, not active element, independent element basically, and initially charged inductor. So this circuit cannot be self-energized. So to energize this system beta, we require some power. Means our testing signal V1 and V2 should deliver power to this two-port network. And how they can deliver power? Only when beta current I1 and I2 direction are this green one. Okay, so please mind it, very important thing beta. These two-port network beta, whatever we apply testing signal, these testing signal will always provide current from negative to positive, so that they can work as a source. And at a time, you can consider sometimes single testing voltage also, or single testing current also, if you want to calculate only one or two parameter of the circuit. Okay, not all parameters. Now see dear, beta ji, in this two-port network, as I told you, the current will flow -2 plus and -2 plus, and again I am going to draw another two-port network beta. Okay, it is our two-port network. Okay, now see my dear friend, if we are using beta this type of battery, minus here plus, just opposite of it, and minus here beta plus here. Okay, now minus plus and minus plus, it is our first testing signal, it is our second testing signal. Due to this beta, current I2 will flow in such a way, and here current I1 in such a way. Okay, so it is also two-port linear network. Now see dear, if your connection are something like this, okay, something like this, beta ji please mind it, your voltage polarity, wait a moment, if your beta testing polarity is something like this, the direction of current will be this one. If the polarity of supply or testing voltage is reverse, then the direction of current will also change. Okay, now see dear, this is the second possibility. Now beta, if you want to apply in place of testing voltage, testing current sources is also right, no issue. Answer whatever will come will be same in all cases. Doesn't matter you are applying current testing signal or voltage testing signal. Okay dear. So beta, here you can see this current source should deliver power. So this voltage is the V1 and it is V2, and again two-port linear network. Okay, now see dear beta, in place of voltage sources you can use current sources, but again these current source must deliver power. So beta, current should flow negative to positive, Similarly beta, if I ask you very simple question, the direction of current is going to change. Now it is beta downward. Now tell me, what is the polarity according to two-port network? The polarity according to two-port network beta is nothing but, see, this is the value of I1 beta, this is the value of I2. Here we can assume minus plus V1, here we can assume minus plus V2. Now you can ask dear, sir, we have taken polarity like positive negative here, but in last case negative positive, why? Because again my dear friend, we required these current sources should deliver power, and this is possible only when our current flows negative to positive. Okay, so please mind it beta, it is again our two-port linear network. Okay, so this is the case. Now beta, in all four cases, see, power always flows from testing to two-port network, in all cases. in all cases. It is clear, dear? Okay, my dear friend. Now beta, we can draw exact equivalent circuit of two port. It will be, yes, something like this beta. I'm going to draw here. Okay. It is a linear two-port network beta, two-port network. Which one is linear? So here, please mind it beta, standard polarity and direction of current are the standard current direction and standard voltage polarity, standard voltage polarity and standard direction of current. So this is the standard two-port network circuit. Standard two-port network circuit. Network. Okay. Now see dear beta ji, how many number of variable here? How many number of variable? 4. Okay. So please mind it beta. Any two-port network, any two-port network may have maximum 4 variables. Maximum 4 variables. Okay. And these may be beta V1, V2, I1 and I2. I1 and I2. Okay dear. Now beta please mind it. Out of these 4 variable, 2 will be independent. 2 will be independent and 2 will be dependent. 2 will be dependent. Okay dear. Now my dear friend, keep this basic theory of two-port network in your mind. Now we are going to discuss testing method to measure circuit parameters. Okay. Now see dear, in testing method to measure circuit parameter, we have already discussed. Now what it is beta? Again I am going to draw one network in such fashion. Here we have I1. This is beta V1. Here we have I2 and it is V2. Okay dear. Again it is linear two-port network. Okay. Has beta initially uncharged inductor capacitor and dependent sources. Please mind it beta. Independent sources are absent. Initially inductor or initially charge inductor and capacitor are also absent. If your inductor and capacitor are initially charged beta, you have to eliminate that charge, then you can design a linear two-port network. Okay. Now see dear friend, out of these beta 4 variable, you can say, you can determine beta V1 by I1. Please try to understand V1 by I1 ratio. You can determine I1 by V1 ratio. You can determine beta I1 by V1. Similarly, V2 by I2 ratio you can determine. Similarly, beta I2 by V2 ratio you can determine. Same way, beta I1 by V2 you can determine. I2 by V1 you can determine beta. V2 by I1, V1 by I2 you can determine. Resting, just continue. I1 by I2, I2 by I1, V2 by V1 and V1 by V2. These components we can determine with the help of this method. Okay. Only these components beta G we can determine with the help of this method 2 port. Now my question is beta, okay, Ibrahim Ahmad. Okay dear. Now my dear friend, okay, Ibrahim, if you have beta any doubt, please let me know. Now see dear beta, I would like yes, okay. Now beta, we want to determine how can we calculate all these parameters. So see my dear friend, okay. Now beta see here beta, please mind it, at port 1 this is A, that is B, this is beta C, it is D. Okay, at port 1 you can take V1 testing signal, and at port 2 you can take beta V2 testing signal. Just come with me and try to understand what I want to say. Okay, so beta, one method we have where V1 and V2 are testing signals. Second method beta, I1 and I2 are testing signal. Another method beta, I1 V2 testing method. Another beta, V2 I1 testing method. Okay, testing method. Another beta, V1 I1 testing method. Okay, another one beta, V2 I2 testing signal. Now these are the maximum possibility to apply testing signal here. And please mind it beta, at a time only you can take two testing signal. These testing signal can be voltage source or current source. Now please mind it beta, if you are taking voltage, wait a minute beta, if you are taking V1 V2 as a voltage signal, then beta please mind it, V1 and V2 will be dependent variable and I1 I2 will be independent variable. I can't write because we have a lot of features regarding it, so just listen to me carefully. Okay, especially beta Abraham. Okay, now see beta, if V1 V2 are testing signal, then these variable will be dependent, whereas I1 I2 will be independent. If you are taking I1 I2 testing signal beta, then I1 I2 will depends upon V1 V2. So I1 I2 dependent and V1 V2 independent. If you are taking beta I1 V2 testing signal, then I1 and V2 will be dependent and V2 I1 will be independent. Similarly rest. So beta, all two port network has four variables, okay, out of four variables beta, two are dependent and two are independent. It is clear? Okay dear. Now beta, my question is, what is the need of this ratio? This ratio beta, whatever we have written here. See beta, if we calculate V1 by I1, V2 by I2, and beta V2 by I1, V1 by I2. Okay, see, I am mentioning here by different color so that it will be very easy for you. Okay, see beta, we can determine V1 by I1 ratio, V2 by I2 ratio, V1 by I2 ratio, and V2 by I1 ratio. The unit of all four ratios will be ohm. So this method 2 port is useful to calculate impedance or resistance. Please mind it beta. Due to this ratio, please try to understand, due to this ratio, this method is important to calculate like impedance or resistance. Now see my dear friend, again I am taking beta Yeah, impedance or resistance, both word we can use beta, please mind it. Okay, now beta I am taking C. Okay, so it is very light color, so even I am not capable to observe it. Now beta I1 by V1, I2 by V2. Similarly beta, where I have written, yeah, I1 by V2 and I2 by V1 beta, please mind it, unit wise mho. So we can also calculate mho, admittance or conductance. Okay, we can calculate. So two port is very useful to calculate impedance or admittance. Now beta, third point we are going to take. Okay, third point is, yeah, G. Yes beta, or G, definitely beta. Now beta I am going to take, please mind it, I1 by I2, I2 by I1, V2 by V1, V1 by V2. Any other? Okay, completed. So beta I1 by I2, V2 by V1 are nothing but gain, are nothing but gain. So how many different components we can calculate with the help of two-port network? Beta impedance, admittance and gain, not for one anything, and gain. It is the last thing. Now beta, due to impedance or admittance and gain, how many different type matrix we can design? It is our next question. Different type matrix beta, please mind it. I am going to draw here again beta one two-port network, and you know what is the standard two-port network. I told you many times, okay, in the same session. So it is I1. Now you have to take V1 and V2 in this fashion, and it is linear two-port network. Okay, now beta see, first we have ohm, so we can derive Z parameter. Second beta, we have Y, so we can derive admittance parameter. Third beta, voltage gain, current gain. That means, please mind it, we can determine voltage gain as well as current gain. Okay, it is the point beta. Now see beta, V1 by I1 is the input kind of impedance, V2 by I2 is the output beta. What about V1 by I2 and V2 by I1 is transfer, is a transfer impedance beta, please mind it. So my dear friend, this particular circuit or this particular method is very useful to determine input impedance beta, or Y you can say, output impedance, or Y transfer beta, please mind it, transfer impedance or Y. Now beta, V2 by V1 is voltage gain, so it is capable to calculate forward voltage or current gain, as well as beta it is capable to calculate reverse voltage gain and current gain. Okay, okay, sure dear. In this session beta, we will complete entire two-port network, okay, in around 7 to 8 session. Complete two-port network. It is the basic idea why we want to consider two-port topology in the circuit theory. Okay, now see dear, we can calculate all these things with the help of two-port testing method. Now my question is beta, can you tell me where we can use this two-port topology? Where we can use this two-port technology? That means beta application of two-port. In which field we can use it? In which field we can use it? Abraham, do you have any idea beta? In which field we can use two-port topology? Okay, now dear friend beta, our question is why we require study of two-port network. Okay, why we require? You are from beta E branch or EC branch, electrical or electronics? Which branch? So beta ji, now we want to discuss where we can use this topology. What is the main application of two-port network? Now see dear, beta, sometimes sorry, wait a minute beta. Yes, I'm writing here. Okay, I will discuss this theorem sometime later. Now see beta, sometimes we have one system beta, and we can't check internal component of this system. Suppose beta it is very complex system, and we are not capable to calculate the total resistance of this body. In that case beta, we apply one ohm meter across the terminals, and this ohm meter will give us the resistance of this body. It is called two-port topology. It is called beta two-port topology. But for that we have measuring device, different type. Obviously, in two-port topology beta, we have to also use measuring device only measuring device. But when it is very useful, please mind it beta. Two-port network is very useful in communication lines as well as in power system lines. Okay, so beta it is very useful in communication system and in power system. Okay, especially beta power system. Why? Because beta suppose sometimes we have a length of transmission line is around 8,000 kilometer. So it is not feasible to calculate impedance, conductance, resistance, everything by meters. In that case beta, by output and input port testing, we can calculate transfer impedance as well as input output impedance. Can you tell me beta, at what condition maximum power will transfer? Maximum power will transfer at what condition? But a maximum power will transfer when load impedance is equal to characteristics impedance. Now see there, in electrical, we never try to achieve this condition. In electrical, like in electrical machine, for example, in electrical machine, I'm not talking about power system, because in power system we require this condition. So beta, especially in electrical machines, see, we are not supposed to maintain this criteria, because at this condition beta, according to maximum power transfer theorem, only 50% power will deliver to the load. But beta, this is the maximum power which you can deliver through the communication line. So maximum power concept actually coming from the electronics field, not from the electrical core. Okay, why? This concept is very useful beta in traveling wave phenomena. Traveling wave phenomena, that is the application. With the help of two-port topology beta, we can calculate each impedance, voltage and current gain, so that we can easily model our system in such a way so it introduces minimum things about reflection and refraction coefficient. Okay, but we don't require that much of depth, okay beta, in this topic. But please mind it, I told you where that two-port topology is mostly used. Okay, so this is a thing. Now dear beta ji, suppose sometimes in BJT, in MOSFET, IGBT, diode, electronic devices, okay, electronic devices, it is not again easy to calculate. It is not again easy to calculate beta ji, input impedance of BJT, output impedance of BJT, transfer impedance of BJT, current gain of BJT, voltage gain of BJT. For example beta, a BJT is this one, and very complex device internally. It is not easy to use meters somewhere here, somewhere here, somewhere here. So we can use beta here some testing voltage, here some testing voltage, here some testing voltage. Only these possibilities are available in BJT. So beta, to handle very rigid and complex system, we require two-port topology. Two-port topology. Okay. So beta, these things are very important. Or two-port method is very important, especially in this field. You know very well, circuit theory is not a subject beta. Kind of. According to me, circuit theory is not a subject beta. Because, see, in circuit theory, we studied how to handle the circuit. How can we calculate current, voltage, power factor, efficiency, okay, and wait a moment beta, not efficiency is wrong in circuit theory. In circuit theory, we want to calculate current, power, and power factor, reactive power, real power, like that term. But nobody will ask you, okay, 99.99% cases, what will be the efficiency? Because but in circuit theory, whatever circuit we handle, those circuits are not a system in general. Those systems are not practical system in general beta. Practical systems parts, okay, are available in the circuit theory. Actually, scientist or professor will guide us in such a way so that we should be capable to handle a small circuit, and after completing all this knowledge or all this theory, you should capable to handle huge system like electrical machine, communication, power system, analog circuit, etc. Okay. So in circuit theory, basically all subject are introduces, or circuit theory gives the basic idea about core. That means how we can handle our core with the help of circuit theory. You know, KVL, KCL, something. Okay, these are a small part of your circuit, not entire. Efficiency, transformer, motor, any system we can calculate. And generally that type of question they will not ask in circuit theory. So the two-port technology is nothing but in somewhere we can use, and sometimes it is very useful to handle our system, to calculate whatever we have discussed. Okay dear, it is a thing. Now my dear friend, my question is, okay, my question is beta, can you tell me why we require superposition theorem to handle two-port network? Or do you have any idea? Beta, we use two-port network, we use this superposition theorem in two-port network or not? Do you have any idea? Please tell me. Is there superposition theorem is beta important for two-port network? Or in other words, in two-port analysis beta, we have to use superposition theorem or not? Or not? Yes, everyone. Okay, no issue beta. See, as I told you, two-port network are beta linear network. Okay, linear network. And in linear network beta, you know, superposition is nothing but follow linearity and homogeneity. Here beta, in two-port network, see, at a time only one testing signal will be active. Okay, one testing signal will be active. So either we have to assume I20 or V20 or I10 or V10. Okay, out of these four variables, we have to assume beta one variable should be 0. Okay, it means, in other words, we are applying superposition theorem. But due to this superposition theorem, your inductor and capacitor should be initially uncharged. Okay. Now, so I think two-port topology. Okay. Now, dear, in tomorrow's session, we will discuss most important thing related to two-port topology. And I will guide you how can we handle any example, okay, either of conventional exam, ES or AS, as well as GATE. And also I will guide you beta how can we score good marks in the circuit theory. Okay, so we will see and meet tomorrow at the same time with a two-port part 1 on Unacademy YouTube session. Okay, thank you. Okay, so dear sir RD, please contact me or WhatsApp me on my number. Okay, here I can't help you related to that type of topic. Okay, so just call me at this number or you can WhatsApp me. Okay, dear. Okay, so thank you everyone.